base this on is largely, as the faculty, we listen to presentations and we have this scoring sheet that we actually do scoring of student presentations. And then you all also do the comments sheets that Amanda types every week, and she types, it's basically like probably the top 8 things, wouldn't you say?
Yeah.
Like there are 8 things that people say, oh, you need to work on this. That's what this is based on. And this is not specific really to seminar. A lot of it applies to any presentation that you're going to do in any class. So some general tips. And for your presentation to be good in any class, these 5 things are really important. So you need to have some knowledge about what you're going to talk about. And that takes time to prepare. So do you know what you're going to talk about? Do you know who you need to be delivering it to? That's going to change depending on who your audience is. Once you know those 2 things, you can plan the structure of your talk before you actually start making slides and graphics and words and so on. And then is the part where you actually stand up and give the presentation. So those 5 things are the major things to keep in mind when you're developing any kind of presentation. So the first one is you need to know enough about the topic. You need to have time to prepare. Those of you who are going to present your own research, you already are really going to know a lot about the topic because you've been doing your own research for quite a while. If you are doing paper-based research, which many of you are, you don't want to wait too long to start getting familiar with that field and the major concepts and the major issues and so on. So make sure that you have enough time to get the background knowledge and then to plan how you're going to use it in your presentation. And then you have to actually make your presentation. And then you have to practice the presentation. So I'm sure that you've all given presentations that you finished the slides 10 minutes before you went in. You don't want to do that for science. So the bigger the presentation, the more time you need between the build and the delivery for the practicing. Something to keep in mind. We have a requirement that you will practice at the Speaking Center before you come and present in here in seminar, and that's 5% of your whole grade. That's a decent amount of your grade. So please remember to do that, especially those of you going soon. Make an appointment with the Speaking Center, practice it for them, and the purpose of that is so that you get a perspective of what it's like for somebody who has no idea about, what's your thing, Elijah? Graphs?
Yes.
Graph theory.
Yeah.
You get a perspective of what people that don't know anything about graph theory, what kind of questions they're going to ask you and what's confusing. And they'll tell you things like, I can't see your picture, or you're talking too fast, or you need to talk louder, you need to stop playing with your hair, those kind of things. So make sure to do that. Technically you don't have to do that, but it's 5% of your grade and it's an expectation. Normally your advisor will want you to practice with them at least once. For me it's twice. And then if you need more, we'll do 3 times. But that's important so that it's good before you come in here. So you need time for all of that. The second thing, Bruce has dirt on his face. It's distracting. The second thing is to know who you're talking to. So when you prepare your seminar presentation, I know that you're like hyper-focused on the faculty, because the faculty do your grade and the faculty are going to ask more questions and so on, but it's really for the other students in the room that's who your audience is. So this picture is of Dr. Fitzmacher's research lab from several years ago. And within her lab, she had people of different ages, different majors. This was an English major that was a work study for that lab. And one thing that they did very well is to frame their information in a way that it would make sense to everybody, and also that everybody would care about it in the first place. So you need to think about, okay, you're giving your talk to people in here. What do they actually know about what you're going to talk about? What can you assume that they know? And so for biology majors, you need to start with what everybody knows, which is maybe like Bio 1 level. And for physics majors, you kind of want to start at general physics level, if you can, so that everybody can have a chance to follow along with you. I always feel like I got to sit up real straight for physics and math talks, like on my game, because I'm not familiar. But good talks will work if you base it starting from what people know and then build up from there. The other thing is make sure that you give people a reason to care about what you're saying. Why should anyone care about core stability? Like with Lawrence, she's talking about core stability. Why should people care about that? Why should people care about how much fat droplets accumulate in worms? Right? Should people care? Yes, actually. But make it obvious why people should care. Or for Bonnie's, why should people care that algae are growing on rocks in caves? She'll tell you why. But don't assume that everyone is crazy about this as you. So give them a reason, some context to care about it. And then this one, your advisors will help you with this, but sometimes you can think of, okay, if I was sitting out there and I didn't know anything about graph theory, what are the usual questions that people ask about graph theory? I don't know. What is it? What's an example of it, you know? What'd you say?
Just what is it is usually
Yeah,
the
what is
question.
Yeah. Yeah, I'm thinking of some other talks coming up. Tristan, what is your topic?
Vaping.
Vaping?
Lots of interesting questions about that.
Yeah, you could probably predict some vaping-related questions. Here's another question for you. Who in the faculty knows the most about vaping? Or things related to vaping?
Vaughn, Rudd.
Probably Vaughn and Rudd. Who else is yet to go? What's your topic?
Cattle castration.
Cattle castration. Who in the faculty knows the most about that?
Probably Vaughn or Rudd.
Vaughn and Rudd again. Who else is going this semester? Austin, who in the faculty knows the most about water quality and toxicants?
Probably Vaughn.
Probably Vaughn.
Maybe Rudd.
Who in the faculty knows the most about immune system dysfunction?
You.
So you need to know that. The reason I have this up here, that's why I'm, your advisor. Hopefully your advisor is the person that knows the most about that. But if there's somebody in the faculty, like if your talk has a lot to do with genetic treatments and genetic engineering, you need to ask yourself, what is Dr. Han likely to ask me about this talk, because that's his specialty. Or if your talk is about a drug, and you're talking about the drug, there's somebody in here that wants to see the structure of the drug. Who cares about that? Dr. P wants to see the structure of the drug, and he really wants you to say something about the chemical nature of the drug. And if you don't, he's going to write it on the sheet, like every time. How many times?
Several.
Twice, at least this year. So, you know what faculty you're in here. You know kind of what interests them and what questions we tend to ask. So try to, prepare yourself And if you don't know, ask your advisor. We kind of know what people are likely to ask. Okay, so once you have spent the time to generally prepare and you've thought about how to explain this to other students and what kind of questions are likely to come up, then you really need an outline. Please do not just start making slides because you're like, I think I'll make some slides now. Please make an outline of how you're going to structure this talk to make it make sense. And ideally, it will kind of be like a story. So generally, it's nice when you start to say, how did you even get interested in this topic? What made you care about graph theory? Or why'd you pick vaping? Or how did you end up interested in cave algae? How did you get associated with the mollusks, clams, whatever you're working with? How did you get interested in that? And then ask yourself, what do I need to say in the background that people don't already know in here? So, like, you probably don't have to tell people what vaping is, because I think everybody knows. Everybody knows, right? You don't know? maybe you should show a picture of it. But if you're talking about, like, what is your organism?
Medionitis conraticus?
Yeah, nobody knows what that is. So I like to pick on Austin because he has like the most funny topic to me. Nobody knows what that is. It's like a clam.
Yeah.
I don't want to give too much away, but you know, people don't know that much about clams, but vaping, that's everywhere. So you wouldn't need to spend 5 minutes talking about vaping and what it is, and how the cartridge works. So think about, what do people already know, and then what else do they need to know? Like, are you going to have a definition of castration?
Probably.
Are you?
My first did a little.
Really?
Yeah.
Okay, well, that's, maybe you need that. Maybe you need that. I don't know. You got to figure out what do most people know, and not be repetitive and not say things that is just real obvious, but what background is needed to understand the rest, the meat of your talk. Okay. So, then once you know that, what is the right order? What order do you need? And what in your talk is going to be difficult to explain? What's so difficult to explain? Judy, what's difficult to explain in your presentation?
I'd say the methods of like extracting RNA and that crazy stuff.
Methods of extracting RNA.
Yeah.
A lot of our presenters are traveling today. Kelly Rivenbark, what's difficult to explain in your seminar?
I guess just how I do everything.
How you do the methods?
Yeah.
Yeah. How the methods work. A lot of times that's the hard thing to explain for most talks. So most of your time needs to be spent on explaining what's difficult and then giving the context in the background for people to understand how that works. I thought Macarena really did a good job explaining what she did, and she made all of those cartoons to explain, this is what I did, in a quick way to make it visually easier to understand. So when you're doing your seminar presentation, the circle of the orbit that everything moves around is data. So either data that you made yourself because you did that research, or data that you got from papers. And if you're doing paper-based research, you really need 2 data figures out of 2 papers, so 4. 4 to 6, with 4 being the minimum. And this is the heart of what you're going to show, because this is science seminar and there's no science without data. So I always tell students, work backward from the data And when you look at a figure like this is a dose response curve, you will have looked at the figure for probably like 6 hours yourself before you get in here, but nobody else has seen it before. So you need to let people settle and look at this and have time for their brain to interpret what does this mean, and you will be helping them with what you say, but what are the things in this figure that people would need to understand to appreciate what that even says? This is visible. So if you had cell biology, this would be like your to be explained list. What needs to be explained for people to understand this?
The abbreviations.
The abbreviations. So what is CYP1A1 and what is TCDD and B6 and D2? I just randomly got this off the internet. I don't know what these are. What else would need to be explained about this before people can interpret it? The shape of what?
The curvature of,
The shape of the curvature?
yeah, like that, why it looks like that.
Yeah. Yeah.
Why is the bottom more logarithmic?
Why is the bottom more logarithmic?
Yeah, I mean the x-axis part.
Oh yeah, down here. I didn't even notice that yet. That's good. Why is the bottom logarithmic? I don't know. We would need to know error bars. Anytime that you put up a data figure in here and it has any kind of statistical marking, the faculty are waiting for you to talk about it. And if you don't talk about it, we generally will say, will you please go back to blah, blah, blah figure, and then we'll ask you a question about it because the statistical markings are important to understanding that figure. So if this was my figure that I needed to talk about, my background information needs to cover what is TCDD. It's probably some kind of dosage per body weight. And what is CYP1A1 and why should we care about its activity? And like why we're looking at these two vitamins. I think this is vitamin B6 and D2 probably. So I would need to have that in the background. Don't wait till you get here and then tell people, oh, CYP1A1 is an enzyme, blah, 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 and you just say it with your mouth. It won't stay in anybody's head. That needs to be in the background. So take your data and work backward to know what do I have to put in the background and what do I have to explain before this to get people to understand. Okay. What does that picture mean? Don't use your slides as a crutch. So you want to have the slides be nice for people to look at. So mostly pictures, not a ton of words. And I don't, just as a general rule, any presentation that you're going to give, try not to go more than 2 slides without a picture. Even if you have to just find some basic image somewhere, don't go more than 2 slides without a picture. It really helps the audience to have visuals to go with the words. And sometimes you'll need to make a picture. I'll come back to that more in a minute. But one thing, when you have made your slides and you've put a certain amount of words on there, some of you who are really nervous speakers will want to memorize the words so that you know exactly what it says, and then you'll stand here and like say the words that you memorized, and then it looks like you're reading off the slide even if you never turn around. Try not to do that. Technically that's a sign of excellent preparation, but it still looks like you're reading off the slides. If you want to have note cards, you can have note cards. If you want to do the thing where you put notes on the computer screen and you're able to see it and the rest of us can't, that's fine. but most of the time you want to be looking at people. So remind yourself what you've got up there. Mostly look at people. Walk between and point. As a group, you all tend to be this side focused because most of the faculty are over here. And so you all feel ignored during semester? Do you think people look over there more? I feel like they do. I write that all the time. Please use the left screen. So you want to use both screens. Point like Vanna White. You know who that is? On Wheel of Fortune, she's like, ooh. And then she walks over, turns the letter. You want your slides to be a guide, mostly for the audience, not a crutch for you to read off of. When you give your presentation, you're going to need more than just the data. So yeah, you need data, but you've got to have other pictures besides the data. Some of it you'll need for your background. Some of it you might need for explaining methods. It's worth looking for good pictures. It's worth looking for good pictures for a while, and then if you can't find one that you really need, then go ahead and make one. That's a hassle, but it can be worth it. So since, I'll keep coming back to Macarena's talk, because it's fresh in my mind, she had made so many pictures that made her talk go so smoothly. So she had like pictures of the worms coming over and they're like dropping into the tube, or am I just,
Yeah.
they were really helpful. And if she had not had those, it would be really hard to explain. If she's just trying to describe it to you with words and she didn't have the pictures, that wouldn't be as good. If you're going to talk about a metabolic pathway, you're going to need a picture of it. There may be a lot of pictures available. This one I kind of like because it's got pictures of what organs we're even talking about in this hormone cascade. Like some things are made by the liver, and then they're going to act in the kidney, and so on. It's worth looking for good pictures. So, this is a little bit out of order. I want to go to an example of a not good picture. Okay, do you ever feel like this is the kind of picture that people show in science seminar and you're like, I can't, where do I look? A lot of the pictures that you'll find on Google Image may have the part that you want to talk about right here, but it's just too much. So the more time that you have to look for good pictures, the better. Try not to show more than you really need to show, because people just shut down when they see this. I do. Brain static. Don't make it too complicated. If you find a picture that you really like on Google Image, it's fine to use those. This one has a good amount of information without being too much. It's about how do you sequence genes from organisms that live in the soil when you don't even know what lives in the soil. So this is a good example picture of showing, without too much detail, this is the process of doing metagenomics. If you use a picture from Google Image, please put where you got it. So this has where you got it. It's from a journal, actually, called Micro. It's best practice to put where did you get this figure if you didn't make it yourself. And I prefer in seminar for that to be on the slide so that I don't have to wonder later, did you eventually have that citation or did you not? This kind of picture I like. If you've had cell bio with me, you've seen this really a lot, or maybe it was Micro, but it's big, it's easy to see, it's got recognizable objects on it like a rabbit that people can, yeah, that's a rabbit. And that's a mushroom, and I remember that those decompose and so on. So don't be afraid to use pictures that are maybe kind of basic, because remember who your audience is in here, it's other students. So the picture can be basic and still okay. If you cannot find a picture that you really like, or they're too complicated, and you feel like you need to make a picture, there's a lot of ways to do that. You can do it in PowerPoint. We've had students hand draw pictures that are nice and work well. It doesn't have to be art like Wyatt's, but if you're good at drawing and you want to hand draw pictures, that'll work. You can do that. And I'm using, again, Maki's presentation from a couple of weeks ago as a good example of how to do that. Are you going to have to make a picture? Possibly.
Yeah, I don't think there's very something that's gonna line up.
Yeah. Have you had to make pictures? Don't know, yeah. It's in April. We've got so much time. Are you going to have to make a picture?
Quite possibly.
Maybe. Okay, then about pictures. Can you tell what this is? What do you think?
It's an astronaut.
It is an astronaut. How long did it take to tell that that's an astronaut? And then, like, isn't your first thought like, oh my gosh, couldn't you find a better picture than that? So try to avoid your pictures being grainy. And the more time you give yourself for your talk, the more time you have to find pictures that aren't grainy. If you must have that picture, make it smaller. Make it smaller to reduce the graininess, but try not to have a grainy picture. Something else is if you're going to be showing pictures they've got a dark background and you're looking for something to glow, you can ask somebody to turn the lights on and off for you. I'm really bad at it, but there we go. So if you need the lights off at a certain point, you can get your advisor or a friend to do that if the lights need adjusting. Not appropriate. Okay. So once in a while, maybe you need to describe a process. Like with Lauren's, she got Leo to come up and show the squat. If he did some kind of squat. And she checked with us before, is it okay if I do that? And we said, yes, if it's, a minute, 90 seconds or less. Once in a while, people will really need to show a video. And that's fine too, as long as it is pretty short compared to the whole length of your talk. So if your talk is currently at 18 minutes and your video is 4 minutes long, that's not okay. If your talk is 25 minutes long and your video is a minute and a half and it's helpful, that's good. Anybody planning to show videos so far? Animations. Sometimes for physics talks we've had animations that are very helpful to any of us to understand the concept. If you're going to show a video, make sure you test it down here. Make sure the sound is going to work and all of that. And that would be fine. What if you need to show a giant data table? This is another thing that happens really frequently in science seminars. You've got this giant data table, and I want you all to be looking at infants that are 36 to 47 pounds and their dosage in the soft tablets. What? 36 to 47 pounds, dosage in the soft tablets. That's kind of hard to find up here because this is a lot of information. So a lot of times your data is in the giant table, but there's helpful ways to deal with that. So at the very least, I picked the wrong column, but you could crop the stuff that you're not going to talk about. So cut it off. Cut it off of the picture and just use the part that you need. How many of you know how to crop images? like do image stuff in PowerPoint. That's what I should have talked about today. That's more needed. That's what we'll do the other TBA day. That's what we're going to do. Image processing. If you don't want to crop it, or if you can't crop it appropriately, you can do, you can circle it. This is also pretty easy to do in PowerPoint to get people to look where you want them to look. You can put a highlight box on it. Just do something. Do something so we know where to look, so it's not so overwhelming. And if none of that will work and you have no other option, you can also take this information and make your own data table that's small and simple if you need to. That's okay as well. Takes more time, but it's much easier to look at in some cases than trying to get people to look at a certain spot in a data table with 60 boxes. Okay, next one. When you're making your presentation, you need to know kind of for the room, for the size of the room, what's the right font. Somebody recently had the most painful giant font. And it came up, and like, oh my gosh, it's attacking me. Big giant font. So for in here, this is showing in this room, for this screen, what are the different font sizes and what's visible, and you really shouldn't go below 20 for this room. When you practice, this kind of stuff will come out when you practice, and somebody will say, oh, that's too small. Or I will say, Dr. Pickard's not going to be able to see that. It's always like that angle over there. So for audibility and for visibility, he is your, think of him. You want him to be able to hear it, you want him to be able to see it, and you adjust your fonts appropriately. Also, notice this is not great and this is not great for visibility. It's just hard to see against that background. So when you're working on the words part of your slide, you don't want to have too many things on at once. So they ought to look kind of clean. It ought to be obvious where to look. It ought to be easy to read. Don't use cutesy fonts. You really shouldn't use italic. I think I have that up here as a bad example. Oh, this has been really good, and nobody has done this lately, but you ever seen a PowerPoint where the thing like zooms in, or it flips and does a somersault and then the words settle down? Don't do that. Don't do that. And nobody has been doing that, but we used to see that a lot in seminar.